Today we're going to be solving for the honors study guide question for the Unit 3 Algebra 2 exam. We are dealing with area problems on these situations. So, a local volunteer group plans to build a community garden. The outline below represents the proposed shape of the garden. And on your paper, you have that this side is 2x minus 6, and yours says feet. And then this is 2x feet. And over here you have 4x minus 6, and you have 8x plus 10. And all of these on yours are labeled in feet. And it says, write an expression for the area of this proposed garden. Show the reasoning you use to find your expression. Well, let's remember that the area formula for a rectangle is length times width. So the area formula for a rectangle is length times width. But this is what we call a composite figure because it's a rectangle with another rectangle. There are three distinct ways that all would be strong representations of how to solve this problem that I can see at the current time. So there are three approaches you can take. One is you can find the area of this larger rectangle, and then you subtract that smaller rectangle. Another approach you can do is to break this composite figure up into two rectangles. And there are two ways to do that. I could break it apart here and have a rectangle over here and a rectangle here. Or I can do it right here and have a rectangle here and a rectangle here. This is how I'm going to do it the first time, and then I'll go ahead and show you one of the other ways as well. So something important to be able to do this is I need to know the missing sides of my composite figure. So, for example, this side right here, we are missing its value. So we need to actually know what this length is. We're going to need to solve for this length. So the whole length is 8x plus 10. And the little part cut out of the composite is 2x. So if the whole length has 2x taken out of it, you'll be left with this shorter portion here. So I need to take 8x minus 10, plus 10, sorry, and I need to subtract from it. So I need to take the binomial 8x plus 10 and subtract from it the monomial of 2x. So this becomes 8x minus 2x, because the minus goes with the 2x, and then the plus 10's on the end. 10 will not combine with anything. I combine my like terms, so 8x minus 2x is 6x. So this missing length over here is 6x plus 10. Now I need to find this missing length. So I know the whole length is 4x minus 6. And I know 2x minus 6 is this little length. So I need to figure out how do I turn 2x minus 6 into 4x minus 6 to get this missing distance. And so one way to do that is, again, subtraction. I take the whole length and I subtract from it the piece that's cut out. Now on this one, I'm going to write in an extra step because I want to distribute that negative now that there's two terms. So I get 4x minus 6, and then that becomes negative 2x. And when I distribute again, that becomes a positive 6. So now I want to combine my like terms. 4x and minus 2x are like terms. 4x minus 2x is 2x. Negative 6 and positive 6 are like terms. Negative 6 plus 6 is 0. So my missing side over here is 2x. My missing side is 2x. So now that I have this information, I can go ahead and go about finding my area. Area is length times width. So I want to find the area of this big rectangle. So I'm going to find the area of this portion. And then separately, I'll find the area of the smaller portion. So if I look at this big portion, Its length is 8x plus 10. So it has 8x plus 10 covers that whole length. And then its height is not 4x minus 6. It stops right here, which means it's a shorter amount over here, this 2x. So my area is going to be 8x plus 10 times 2x. And so now I need to distribute. So I'm going to distribute 8x to the 2x. And 8x times 2x is 16x squared. There's nothing else for me to distribute 8x to. So I go to my next term and I distribute the 10. 10 times 2x is 20x. So the area of the big portion of my rectangle here is 16x squared plus 20x. This is not the area of the whole garden. I now need to find the area of this little portion in here. So this is the area of the big portion. And now I'm going to find the area of the little portion of the garden. So the little portion, we can see that its sides are 2x minus 6 and 2x. So I'm going to do 2x minus 6 times 2x. And now I'm going to distribute. So 2x times 2x is 4x squared. Negative 6 times 2x is negative 12x. I now found the area of the little portion of the garden. But I want to find the area of the whole garden. So I'm going to take my little portion and I'm going to add it to the big portion. So my total area is going to be the area of the little portion plus the area of the big portion. So my area of the total is going to equal 16x squared plus 20x plus 4x squared minus 12x. Remember that when we add polynomials, we can just go straight to combining like terms. So x squared and x squared are like terms. So I add their coefficients. 16 plus 4 is 20. 20x squared. 20x and negative 12x are like terms. So that is 8x. So the area of the whole garden is 20x squared plus 8x. But let's go back to remembering units. This garden was, all the measurements were in feet. So if I'm doing length times width, if I'm doing feet times feet, then my area is going to be feet squared. So I'm going to get 20x squared plus 8x feet squared. And it says to show the reasoning. Showing the reasoning is showing all these steps you took to find the missing sides and to find your areas. So notice, it's not that you're doing any higher level operations. You are just applying multiple operations to solve a single problem. You had to apply subtraction, you had to multiply, and you had to add. So you hit the three big operations for polynomials: subtraction, multiplication, and addition. The only operation we haven't hit is division. So now let's look at part B. Part B says the volunteer group has plans to double the area of the garden in a few years. They have come up with two plans to complete this. The first plan increases the length of the base of the garden by b feet, as shown in this picture. So this rectangle is not the same as this bottom rectangle. This rectangle is the total area of the composite figure. So we just found out this composite figure has an area of 20x squared plus 8x. So this one needs to have an area of 20x squared plus 8x. But this one is not a composite. Okay, so this length is 8x plus 10. B is not equal to 8x plus 10. B does not equal 8x plus 10. Because the only way we got this area with that width down there was adding on this extra piece up here. Now, the one thing we do know, we saw that this short side over here was 2x. And we can see that that's still parallel here. So this is still 2x. So that 2x is fixed. That is absolutely the same side. because we can see these lines are still making a rectangle coming off. All right, so I need to solve for B. So if I know the area and I know the width, I can divide to find the length. So if I know the total area in one of the dimensions, I can divide to find the other dimension. So that's going back to the factor theorem, that if I divide by one of the factors, I'll have a polynomial with no remainder. So I'm going to take 20x squared plus 8x, and I'm going to divide it by 2x. And so I ask myself, 2x times what is 20x squared? Well, 2 times 10 is 20, and x times x is x squared. So 10x times 2x is 20x squared. And I subtract that polynomial, that's 0. I bring down the 8x. How can I turn 2x into 8x? Well, 2x times 4 would be 8x. So 4 times 2 is 8x. I subtract and I have no remainder. So my missing side is my missing side is 10x plus 4. And so what was our reasoning? Our reasoning was that if I know the area and the width, I can divide the area by the width to find the length. So something along those lines. Again, your explanation is what logic went on in your head. If there's another route you found to find this answer, then do it, okay? Math is all about finding multiple ways to the same results. Now, I promised that I would go back and do the other problem another way. So at this point, if you're happy with this problem, then you can go ahead and stop the video. But if you want to see other approaches to part A, I'm going to go show you another approach to part A. All right. So another approach to part A. To start with, you still need to find the same missing sides. All right, so we've got to find the same missing side. So that part doesn't change. That subtraction does not change. So I'm not going to redo that work because we still need to know that. No matter which method you choose, you need to find all the missing sides of your shape. Now the next way I'm going to do is I'm going to make a larger rectangle and then cut out this missing piece. So if I look at this large rectangle, then this portion here, my length is 8x plus 10, and my width is 4x minus 6. So if I did 8x plus 10 times 4x minus 6, that would get the area of this big rectangle. But notice I need that missing piece cut out. So I'm going to go ahead and multiply these. To multiply these, and so this is an overestimate of the area. So I'm going to just say the area over. So to multiply, I distribute. So 8x times 4x is 32x squared. 8x times negative 6 is negative 48x. 10 times 4x is 40x. 10 times negative 6 is negative 60. And I combine my like terms. So I get 32x squared. Those combine to be negative 8x. And then minus 60. All right, so that's an overestimate. And now I need to find the area of this piece in here that I have to cut out. And so that piece in there has a length of 6x plus 10 and a width of 2x minus 6. So the area I'm going to cut is 6x plus 10 times 2x minus 6. So I get 12x squared. I get 6x times negative 6 is negative 36x. 10 times 2x is 20x. 10 times negative 6 is negative 60. And I combine my like terms. 12x squared minus 16x minus 60. All right, so now I need to subtract. So my area of the total is going to equal the over area minus the area I need to cut. So it's going to be 32x squared minus 8x minus 60. Subtract 12x squared minus 16x minus 60. First thing I want to do is distribute my negative. So remember, distributing the negative is a lot like changing signs. Okay, so my first polynomial doesn't change. My first polynomial, we're going to leave it alone. And I distribute this negative, and that becomes negative 12x squared. That becomes positive 16x. That becomes positive 60. I copied that number down wrong. That was a 60. We see there is 60. All right, and so positive 60. So now I'm going to combine my like terms. 32x squared minus 12x squared is 20x squared. Negative 8x plus 16x is 8x. And negative 60 plus 60 cancel each other out. So I get the area of my shape is 20x squared plus 8x. So the same way as before. Now this one, perfectly mathematically sound, but notice there is a lot more distribution that had to be done. Now that I had a binomial times a binomial 2 times, and when I subtracted, I now had trinomials. So just be careful if you do this method, because you have a few more areas where you have to combine like terms and could have mistakes. All right, and so again, there was a third way where you could have just divided up the rectangles differently, but you would do that the same way we did the first one. All right, that's it for the honors question.